performing this talk. There won't actually be time for questions, but I'm here for the rest of the week. The ultimate goal of all computer science is the program. Designers, programmers, engineers must once again come to know and comprehend the composite character of a program, both as an entity and in terms of its various parts. 1968, the NATO Conference on Software Engineering. That's Doug McElroy from AT&T Bell Labs sitting up, and the American at the front of the room telling the Europeans what to do, and that's Egster Dijkstra there, the European, listening in and being really, really keen. And what did he say? He says, the general admission of the existence of the software failure in this group of people is the most refreshing experience I've had in a number of years. Did I mention this was 1968? Tony Hoare says there are two ways to live. There are only two ways to make a system. Either you have to make it so complex that there are no obvious deficiencies, or you make it so simple that there are no obvious deficiencies. And the first point of this talk is that these things didn't happen by accident. These things are part of, for want of a better word, an underlying philosophical idea called modernism. And it's a movement in art and literature and architecture and science and technology that in some ways began even right back in the Enlightenment in philosophy and then worked its through to architecture in the late 19th century. And we might talk about modernity as the condition of society resulting from modernism, where everybody lived in buildings that looked like that, or cities that looked like this. And Le Corbusier says, the plan is the generator. Without a plan, you have a lack of order and willfulness. The plan holds itself the essence of sensation. The great problems of tomorrow, dictated by collective necessities, put the question of plan in a new form. Modern life demands and is waiting for a new kind of plan, both for the house and for the city. Corbusier's Radiant City. My colleague Robert Biddle's University. Niklas Wirth says, software engineering program construction consists of a sequence of refinement steps. In each step, a given task is broken up into a number of subtasks. Each refinement implies a number of design decisions. Among these criteria are efficiency, storage, economy, clarity, and regularity of structure. So English researchers characterized what's going on like this with Fordism. Fordism has four basic principles. You know what Fordism is? It's the philosophy of Henry Ford. Standardized products, repeated tasks having the potential for automation, unautomated tasks analyzed using work-study methods known as Taylorism, where you measure the performance of something and then you use that information to feed back and improve the procedure. And production lines with work moving to the workers. Analysis, design, programming, testing. Dahl and Nygaard, I have to mention them. But where are we? Well, we've got a whole world of programs. We've had 50 years of software, probably 65, 70 years of software since I first gave this talk. 30 years, 40 years of software engineering. And software's everywhere. I flew here from New Zealand in two very large planes that were not, I did say these slides came straight from the early 2000s, didn't I? Planes that were designed by software, were built by software, and those planes were basically flown by software. If the software stopped working with the ATM, I wouldn't have been able to pay for my dinner yesterday, or call anybody, or even the lights in this lecture theater. If the software controlling the electric grid failed, we'd all be in the dark. Why is this important? Well, in 1968, if you go back and read the original NATO report, that was the criteria by which computer science, software engineering, programming would have succeeded. that we would have succeeded if you could pilot an airliner across the Atlantic Ocean or you could operate a nuclear power plant. But today, ladies and gentlemen, today, you couldn't imagine doing either of those things without software. So let's consider the most important task in programming. The task to instruct a computer to print a table of the first 1,000 prime numbers, 2 being considered the first prime number. But how do we do this when we're not writing the first program in the world? Okay, it's easy. We go to component source. It was 2000, right? We'll go there, okay? See what they've got. Actually, you could do what some of my students clearly do when asked to do a programming assignment. Or you could do what everybody in this room actually does. So the question in that sense is, what's going on? What's left for programming and for computer science when everything that we wanted and everything that we believed in has already been done? But this situation isn't unique to programming or to computer science. And there's the dread word, postmodernism. Jean-François Lyotard, in a book called The Postmodern Condition, talks about the paradox of the future post, anterior modo, the future past. These guys, Robert Biddle and James Noble, said modern means apply to other than modern ends. And there's a bunch of stuff you can think about making up this sort of postmodernism. Incredulity towards meta-narratives, long French words, some of which I'll explain. Negotiation in context, double coding, reuse, topology. Here's Lyotard again. Recourse to grand narratives is forbidden. We cannot recourse to the dialectic of the spirit or even the emancipation of humanity for the validation of postmodern scientific discourse. Interesting that Lyotard was actually writing out the problem of the modern university, when there's a whole lot of people, some doing computer science and some doing art history, and how would these things operate? And what are we doing? But as we have seen, the small narrative is a form which superbly allows imaginative invention, most of all in science. What are our grand narratives? What is programming? What is computer science? The good thing is there are people that can tell us. There is the ACM curriculum on computer science, and that actually defines what is important. Algorithmic computation, correctness. Okay? If a program is correct, it's apparently worth nothing. Algorithmic efficiency. And to quote Martin Reinhardt, software that fails to meet these goals is evidence of the moral weakness of its programmers. What have we got instead? These things called little narratives. Instead of appealing to some overarching goals, we'll try and make decisions ourselves in our own small part of the world. So people might talk about a negotiation between various different narratives, being open to the environment, decisions being contingent or context dependent. And best of all, no single correct answer. Gee, my students love that. So you have this notion of negotiation right across programming, software engineering, and a notion of local correctness instead of global correctness. So what kind of things does this involve? Postmodernists talk an awful lot about double coding. Double coding is a word for addressing more than one audience or meeting more than one concern. Perhaps your programs have to be acceptable to the general public, but you also have to care about the technical and professional experts, your colleagues. And we still do actually have implementation constraints. But the thing about double coding is it says, look, we prefer the surface to the depth. You know, whether our programming language has curly brackets or round brackets is more important than whether it's type-safe or not. We prefer appearance to reality, signifier to signified. The pictures on the slides are more important than the content. And of course, parody, pastiche, irony, and cute references are all part of this. Where do you end up? Anders Hellsberg, one of the great language designers, clearly influential, actually said this back in 2004. Your choice of programming language is a lifestyle choice. It's a Jamanda, great. Your choice of programming, I mean, I was going to say people have died about choices of programming language, and I was going to say that's not true, but it quite possibly is true if you believe what Matthias Feleisen was saying yesterday in the workshop about why JavaScript is bad. Another way of looking at this is to say that postmodernism is that condition for which, for the first time, and as a result of technologies, this guy's a philosopher. This is the Cambridge companion to postmodernism. As the result of technologies which we have built, which the people in this room have built, allow the large-scale storage, access, and reproduction of the records of the past. And so the past, all the software, all the programming languages, is now included in the present. These days, there's no difference between the Beatles and Beethoven, because both of them are on Spotify. What, of course, this means is that the technologies that we have built are now going to affect what we actually do. How do we make this concrete? Larry Wall's giving a keynote, and he said, way back when I started designing Perl, I lovingly reused features from many languages, from C Shell, Gret, Sed, Awk, Fortran, COBOL, PL1, Basic plus Snowball, List Data, C++, and Python. To the extent that Perl rules rather than sucks, it's because the various features of these languages rule rather than suck. Okay? These languages are put together from parts of other languages. And if you think about this, when you program them, you're referring to those things. Storing and retrieval the past, sum of all human knowledge, is pretty much on the wiki web now. This is why we can Google for the stuff we need to do in our programs. And as an aside, of course, Wiki was produced by Ward Cunningham, who in many ways is the postmodern computer scientist, because he's been in so many important and postmodern developments. And Wiki is, of course, the one we're most familiar with. But design patterns, Ward, again, was very much involved when the design patterns movement, this talk was originally given 15 years ago, was coming along. And what is a design pattern? It's a solution to a problem in a context. It doesn't tell you how to design the whole programs. And frankly, the attempts by some of the patterns people to say, we will write a book, we will write a modern book that gives you a big story about how to design every program in the world, that attempt failed. But the design pattern is a solution to a problem in a context, small stories about bits of designs. That was successful. And patterns don't build whole, complete programs. But what they do is they give you small answers to small parts of your programs, and then they interact and negotiate one another for the whole program to emerge. And of course, there's extreme programming. I think Ward is one of the figures standing around the glowing whiteboard of knowledge. How's this supposed to work? Well, the customer and developers are supposed to negotiate over these things called user stories. And these stories are iterative. It's not the kind of refinement you see if you're doing stepwise development. But, you know, other stuff come in, other stuff not comes in. And the aim of this is to build a system, not build lots of reusable components according to some plan, but put a system together based literally on the negotiation and playing games between the developers and the poor customers who are paying for it. Postmodernism is leaching actually into the code that we write. Each of these annotations is a small thing telling one little thing about this method. There's not a complete set of annotations in Java, and you can add your own in. Each annotation is like a little bit extra of a programming language, a small story about one thing. And we end up with code looking like that. So after we gave the Force talk, we came back next year and gave a second talk called No Name, Notes on Software Reuse. And most of this talk was about what we called scrap heap programming. And these pictures are actually taken at a Wellington scrap heap by Angela Martin, who was a graduate student of ours, who's a photographer. And the idea of this is that programmers don't have a plan. You work bottom up from the scrap heap, starting with whatever you can. Whatever you can find, whatever you can scavenge, perhaps whatever you can steal, certainly whatever you can Google. And then you work out what you can build based on the components you've got. And this bottom-up way of working is completely the opposite to the way of working where you have requirements and analysis and design and specifications. The whole point of something like XP is that you negotiate about requirements based on what's easy to build. Okay, you want this feature, you can have it tomorrow. You want this feature, you can have it next year. Requirements are a result of programming, not an antecedent to it. We actually have building recyclers. This is a company where if you don't need a building anymore, they'll put it on the back of a truck and take it away. In New Zealand, most houses are made out of wood, so if the building doesn't fit on a truck, we saw them in half. And we put them on a truck, and we take them away, and whole buildings and parts of buildings, and if you want a house, you can actually go to a building yard, which is a yard with a lot of houses in them, second-hand houses, and buy one, and then they'll put it on a truck and take it to where you want to live. Or as Brad Cox would put it, well, this is kind of like software ICs, software components. But the point of this is that what you get isn't something that looks like a plan. This is Wellington, and in fact the university is sort of sitting on the hill. This isn't Corbusier's radiant city. This isn't some grid pattern with all the buildings looking the same. It's something that's built out of what's there. Here we walk amongst 2,000, well, probably more than that, 3,000, 4,000 years of history. Even in Wellington, we've got a couple of hundred years of history that shapes our city. Programs are shaped in the same way because we're building up on what's already there, on components that already exist. And if you actually do various metrics on programs, if you ask how big are my classes, or how big are my methods, or how interconnected are my objects, you don't get the uniform distributions or perhaps the normal curves that you would expect if All these things are built out of components that are all exactly alike. What you get instead are power laws, which is exactly the same mathematical relationships that will describe the building of trees, the flowing of rivers, the shape of the mountains, in nature, in cities, and in our programs. We did the talk again a third time. And true to our form, of course, we just reused the previous two talks. We're very careful not to make any new slides. And then we did another talk called Love in the Age of Software, which I believe was the most annoying talk at an XP Agile conference, and possibly why Robert and I were never invited back again. It may have been because we started the session at 8:30 in the morning by playing Kraftwerk extremely loud. Here's the truth of programming, right? So, looking at this, you know, XP is all about tools for customers and developers to rate with each other, but if you think about how it's actually done, things are different. So system metaphor, one of XP's original practices, in some sense this was about saying come up with at least a small story of the whole system, that one's expunged. On-site customers, well, that's impractical and unrealistic. You can't expect someone paying for your software to actually spend time with you telling you what to do. So we'll hire somebody else to be a customer. User stories are supposed to be a promise to have a conversation. Well, we'll automate those things. And when it comes to the planning game, which is supposed to make our development flexible, well, that's kind of a bit difficult, you know, so let's not do that. Where 10 years ago did we think Agile development would end up? Well, all sorts of stuff. One-day iterations, the whole team approach where the whole team is programmers and you don't have one of these customers. Executable user stories, automated acceptance testing, 80-hour weeks, 3 months crisis, and career change counseling. And, you know, we had to ask ourselves the question, ¿Qué es más macho, train wreck or death march? Would you rather be in the planned train wreck where you're all sitting on a train and you're traveling straight towards the wreck and then bang, you hit it? Or would you rather be doing a death march where you work again and again and again and anyway? So where does this leave us? Where does this leave us? Aren't we throwing the baby out with the bathwater? Are we rejecting 50 years of progress and consorting with past-it French philosophers? The point is that post doesn't just mean instead of. It also means follows on from. So the point of this is to keep modern technology, well, the bits that work anyway, but apply it to different postmodern ends. So this raises the question, how can we do software engineering without meta-narratives? Without correctness or efficiency, or at least where both correctness and efficiency are negotiable, in a way I certainly wasn't taught when I was at school. Without a privileged position from which to model or conceptualize, because we know that as programmers, what we do will change the world. The components we find to reuse will set the requirements for our systems. Can we move from a grand narrative to just being one little story above many? Should we? Or in practice, do we really have the choice? If there are only two ways to make a system, either you make it so complex that there are no obvious deficiencies, or you make it so simple that there are obviously no deficiencies, then what the market has shown us, and what we know now, is that we do not have the second choice. We only have the first one. Systems built together out of the past out of what we already have, built by ongoing negotiations between programmers, between customers, between the software that's in the past and the software that's in the future that we will write. In short, we're all postmodern now. Thank you. So I'll return to the present. And that went quicker than I thought it would, so I do have a bit of time for questions.
Hello, thanks for the wonderful talk. I have a question. Is there something that comes after postmodernism?
Postmodernism. The short answer is I don't know. I mean, I was recently looking at some stuff in architecture, and some of the best elucidations of postmodernism are ones that seem to make most sense to me as a computer science, come out of architecture. And the late Zaha Hadid had a form of design she called parametric design, which she basically said, look, instead of building these kind of buildings just out of fixed components, the whole point of doing this is that we will build all these components that are parameterizable. Does that sound familiar to anybody? I think we're still here. I don't think that the conditions have changed. I think that what we have done, what we have wrought, what we have built has basically infiltrated the entire world. You know, it's easier to get cell phone service in Soweto than it is to get sewage. And I think, you know, it's coming back to bite the way we as programmers work. We as designers work. And modernity is here whether we like it or not.
Thank you.
Hi.
Hi.
So I was wondering, so I think today, more so maybe than 15 years ago, I guess a lot of us are steeped in sort of these postmodern things that you've described in the programming practice.
Yeah.
But I still see really strong influences of modernism, in particular the idea of grand narratives, and these seem to be making a comeback with, you know, VCs talking about how software is taking over the world. Do you see any lessons that we could have learned from the modernists, say in architecture and planning, that we have not yet learned?
I think that's a good question. I'm tempted to say don't. The other thing which I didn't talk about because I didn't have time is that, you know, as I said, postmodernism doesn't replace modernism, but it carries on from it. So you can still be as modern as you like, okay? And in fact, again, in programming languages, my field, you know, there are people who are getting more and more and more modern, right? There are people who are doing everything they can with mathematical proof. And if you think about languages like Idris and Agda and Coq, you know, what could be more modern than designing and proving everything and then having a computer system that is itself proved your stuff correct? That's really, really, really modern. We have a plan which is this specification, and then we ensure that the software meets that specification. What does postmodernism have to say about that? I think it has two things to say. First of all, this idea that the signifier, that what we say takes over the meaning, the whole sign, is once we can write specifications, we're not going to really worry about code. We'll just write the specifications. And you know, maybe your manager could read the specification you've written, and maybe you could write those specifications in, I don't know, a common business-oriented language, perhaps. And the other one is that, yeah, there are grand narratives, but there are so many to choose from. So if you look at what's the most, again, in my key area, but you can see this in lots of places of computer science and in the kind of systems people build. Programming languages, the most interesting on the one side are the Agda and the highly typed stuff and the higher order generic Haskells. And the other side is, you know, the double coding. It's the Hello Kitties of the programming languages. It's JavaScript. And again, if you look at either academic research, Or practical development, there's the JavaScript side, completely turning away from modernism. And the nice thing about postmodernism is, yeah, you know, if you want to, you can build a house out of glass and steel and make it a square box. Or you can, you know, put something together out of bricks. Or you can go to a yard and you can buy a wooden house that's 100 years old and move it to where you want it. Or you can move to Rome and you know, move into a building that's 500 years old. The past is part of the present, but it doesn't mean the present's replaced the past, and it doesn't mean the past has eaten the future in some sense. Postmodern, the future past.
Do you have a conception of who is a good software engineer in a postmodern era?
Do I have a conception of a good software engineer in a postmodern era? Well, I think there is an answer to that, because why do you call me good? We are in Rome. Nobody but my Father in heaven is good. Okay? Postmodern, you know, the idea of a good software engineer, if implicit in it, I guess I could say as a criticism, is an idea of a grand narrative. There is some perfect software engineer, whether it's Niklaus Wirt or whether it's Larry Wall, and that is to whom we aspire. That is to whom we aspire, and but postmodernism says, look, there are all these lots of little competing, negotiating things involved in building software. So you have to ask what context for doing what kind of thing. So is somebody who is good at building websites and keeping them secure, perhaps in JavaScript? A good software engineer doing that, a good programmer doing that? Are they going to be the people you want to work, I don't know, on your avionics systems? No. So that's part of it, I think, the context of people, and also being aware, again, that, you know, there are more things in heaven and earth that are probably dreamed of in your philosophy. In some ways, it's easier to see this amongst the sort of the scruffy end, the Hello Kitty, the JavaScript people, because they know that AGDA and functional programming is there. But I mean, some of the most interesting work that's going to be done in AGDA and COP is going to be, you know, in fact, already is. It's building models of JavaScript. Okay, and what's some of the most interesting stuff being done in JavaScript? Oh, gee, it's building implementations of these hyper-modern macho programming languages over here. And you can't make progress in that way if you're saying, okay, look, well, I'm this guy, I'm a good software engineer, and the rest of you are, you know, Brexiters or something. I didn't say that.
So I would propose that what the Peter spoke about earlier on, where you go with the flow, everything gets developed, and analysis tools try to infer specifications, find bugs, and so on, is the postmodern approach, in the sense of it brings back the idea of we want the software to be reliable, but we don't force the software development process.
Maybe I listening to that talk, and it was a great talk. I thought it's also a quintessentially postmodern talk. You know, what could be more postmodern than taking the best leading edge research on some of the hardest problems in computer science and applying it, you know, to PHP? You know, there, in some sense, is the quintessential postmodern, you know, a quintessential example of postmodern computing. I mean, the reason the slide says we're all postmodern because we are all postmodern. You know, what does Haskell want to be? Haskell wants to be Perl. You know, Perl wants to be Haskell. Yeah, there's a book. Okay, that was. Sorry. I can keep going. All right. Sorry.
Not for the whole day.
So yeah, you know, real world Haskell is Haskell wants to be Perl. Perl wants to be Haskell.
So sometimes I wonder if the architects ever
tell stories about use computer science metaphors or software metaphors in their conferences. Do you think there will ever be that time?
Absolutely. I don't even think that architects use computer science metaphors. I think architects are, and have been for the last 50, 60 years, they're turning into computer scientists in some sense. If you're in London in South Ken and you go to the Science Museum, there is a great exhibition on Ove Arup. You know who Ove Arup is? One of the greatest, arguably greatest, most influential engineers of the 20th century. You heard of the Sydney Opera House? He designed that. The wobbly Millennium Bridge in London, he designed that too. The Pompidou Center, he designed that. Or if he didn't design it, he did the engineering that made it possible. And if you go to this exhibition, what you find sitting in the middle of it is a Ferranti Mark I computer. Because the only way they were able to build the Sydney Opera House, and this is 50 years ago, was to use computers to model the shape of the spherical sections which form the roof of the Sydney Opera House. Jorn Utzon won the competition with a sketch on a napkin, and I had no idea how to build it. And so he asks Ove Arup and comes in and eventually works out, well, these things should be spherical sections. How do we know how to build them? Well, we use a computer. Right up to Zaha Hadid and all the kind of skyscrapers you've seen, like the Shard and the stuff being built in China and Dubai. All of these things are only possible because of software. And again, you know, Zaha Hadid talks about their style of architecture, their small part, their small approach, I suppose you could say, as parameterizable in precisely the way that we use the word parameterizable. Why? Well, because they got it from us first.
My question is, like, postmodernism in philosophy is generally understood as here.
I'm blind. Yep. Okay, sorry.
Yep. So the idea is that instead of having an ontology about the world, like postmodernists focus more on a conventionalist worldview, like that the man is the measure of all things, right? Does this proposal sort of reflect the fact that it's impossible to find a nature for a program to define it? Like as mathematical objects or whatever?
So, in the sense that, you know, I'm arguing against grand narratives, I'm saying there isn't going to be one big ontology for everything.
Yeah, but there's a thin line between like a grand narrative and the nature of something, right? Maybe.
So I mean, I'm tempted to say yes, but we all have different natures. We all contain multitudes. You might think of you know, it's just as, you can think of a program as something that runs on a computer. You can think of it as a mathematical object, which has some relation to that. You can think of it as a human architect constructed by humans. You can think of that as an artifact that's evolved over the time and will carry on and evolving into the future. And the postmodern approach is, well, all of those are valid ways to think about artifacts. And I would say, and in fact, we need all of them. We can't just say, look, we're only going to consider the mathematical model of our Java type system as being type safe and not care about the fact that it has nulls in it, which means it's not type safe. It doesn't matter. As Peter said, you know, we can have type systems that means you can't write null in Java or Scala, but programmers don't want to use them. And there may well be reasons for this, not just Tony Hoare's $1 million mistake.
Good, because this is how I understood it, and in my presentation tomorrow I'm going to say that, so...
Excellent, and your presentation tomorrow is?
What is programming?
Hmm?
What is programming?
What is programming, okay.
We're out of time, but let's thank the speaker.
Thank you, I'm around for the rest of the week. By software, were built by software, and those planes were basically flown by software. If the software stopped working with the ATM, I wouldn't have been able to pay for my dinner yesterday, or call anybody, or, you know, even the lights in this lecture theater. If the software controlling the electric grid failed, we'd all be in the dark. Why is this important? Well, in 1968, if you go back and read the original NATO report, that was the criteria by which computer science, software engineering, programming would have succeeded. That we would have succeeded if you could pilot an airliner across the Atlantic Ocean, or you could operate a nuclear power plant. But today, ladies and gentlemen, today, you couldn't imagine doing either of those things without software. So let's consider the most important task in programming. The task to instruct a computer to print a table of the first 1,000 prime numbers, 2 being considered the first prime number. How do we do this when we're not writing the first program in the world? This talk is that these things didn't happen by accident. These things are part of, for want of a better word, an underlying philosophical idea called modernism. And it's a movement in art and literature and architecture and science and technology that in some ways began even right back in the Enlightenment in philosophy and then worked its through to architecture in the late 19th century. And we might talk about modernity as the condition of society resulting from modernism, where everybody lived in buildings that looked like that, or cities that looked like this. And Le Corbusier says, the plan is the generator. Without a plan, you have a lack of order and willfulness. The plan holds itself the essence of sensation. The great problems of tomorrow, dictated by collective necessities, put the question of plan in a new form. Modern life demands and is waiting for a new kind of plan, both for the house and for the city. Corbusier's Radiant City. My colleague Robert Biddle's University. Niklas Wirth says, software engineering program construction consists of a sequence of refinement steps. In each step, a given task is broken up into a number of subtasks. Each refinement implies a number of design decisions. Among these criteria are efficiency, storage, economy, clarity, and regularity of structure. So English researchers characterized what's going on like this with Fordism. Fordism has 4 basic principles. You know what Fordism is? It's the philosophy of Henry Ford. Standardized products, repeated tasks having the potential for automation, unautomated tasks analyzed using work-study methods known as Taylorism, where you measure the performance of something and then you use that information to feed back and improve the procedure. And production lines with work moving to the workers. Analysis, design, programming, testing. Dahl and Nygaard, I have to mention them. I have to mention them. But where are we? Well, we've got a whole world of programs. We've had 50 years of software, probably 65, 70 years of software since I first gave this talk. 30 years, 40 years of software engineering. And software's everywhere. I flew here from New Zealand in 2 very large planes that were not, I did say these slides came straight from the early 2000s, didn't I? Planes that, you know, were designed, okay, it's easy, we go to component source. It was 2000, right? We'll go there, okay? See what they've got. Actually, you could do what some of my students clearly do when asked to do a programming assignment. Or you could do what everybody in this room actually does. So the question in that sense is, what's going on? what's left for programming and for computer science when everything that we wanted and everything that we believed in has already been done? But this situation isn't unique to programming or to computer science. And there's the dread word, postmodernism. Jean-François Lyotard, in a book called The Postmodern Condition, talks about the paradox of the future post, anterior modo, the future past. These guys, Robert Biddle and James Noble, said modern means apply to other than modern ends. And there's a bunch of stuff you can think about making up. Performing this talk, there won't actually be time for questions, but I'm here for the rest of the week. The ultimate goal of all computer science is the program! Designers, programmers, engineers must once again come to know and comprehend the composite character of a program, both as an entity and in terms of its various parts. 1968, the NATO Conference on Software Engineering. That's Doug McElroy from AT&T Bell Labs sitting up, and the American at the front of the room telling the Europeans what to do, and that's Egster Dijkstra there, the European, listening in and being really, really keen. And what did he say? He says, the general admission of the existence of the software failure in this group of people is the most refreshing experience I've had in a number of years. Did I mention this was 1968? Tony Hoare says there are two ways to live, two ways to live. There are only two ways to make a system. Either you have to make it so complex that there are no obvious deficiencies, or you make it so simple that there are no obvious deficiencies. And the first point of